Every single day, intelligence organizations, militaries, and massive global corporations are staring down a literally near impossible challenge. Today in this explainer, we're breaking down a brilliant 2026 paper published in Open Publications by Dr. Enis Kara-Arslan from Mughla Sukuk Kochman University, along with his team of researchers. The paper is called Using Data Science Tools, a case study to identify weak signals, and it tackles a massive problem of modern strategic foresight that all these big institutions are wrestling with right now.
So, think about this for a second. How do you hear a whisper in a hurricane? Because that is exactly the metaphor we're dealing with here. The hurricane is the overwhelming, totally deafening noise of global big data. We are talking petabytes of open-source intelligence, sensor feeds, and just relentless online chatter flowing in constantly. And that whisper, well, that's the subtle, hidden anomaly that tells you something massive is about to happen.
Okay, let's dive into this definition. The research focuses heavily on what they call weak signals. These are subtle, early indicators of emerging trends or events. They're incredibly ambiguous, highly fragmented, and really hard to distinguish from the everyday background noise. It's kind of like finding a tiny digital footprint before the shoe even drops. But detecting them is absolutely crucial. Take military cyber intelligence, for example. A weak signal might be a minor anomaly, a slightly unusual data pattern, or just low-level probing. If you can actually detect that faint whisper, you can reveal a serious cyber threat way before it escalates into a full-blown attack.
Right, so here is our intellectual roadmap for today's explainer. We'll start with the core problem, move to the 5-layer detection model, explore steep forecasting for global threats, discuss the human in the loop, and finally, weigh open source versus proprietary choices. Section 1, the core problem. Beyond human capacity. Let's start with the fundamental flaw in how we've traditionally tried to look over the horizon. For decades, organizations relied on standard horizon scanning and expert panels. You get a room full of brilliant subject matter experts, and you basically ask them to connect the dots. But as the research clearly points out, the human brain simply cannot scale to process today's massive data environments. We just struggle with the sheer speed and volume of modern data feeds. Plus, let's be honest, expert panels are vulnerable to cognitive biases like groupthink. That's where critical, out-of-the-box signals get dismissed just because they don't fit established paradigms. Human experts are incredibly valuable, for sure, but without automated data science tools, they will inevitably miss those critical weak signals. Section 2. The 5-layer detection model, from noise to insight. To solve this massive human scaling problem, Dr. Kara-Arslan and his team propose a really remarkable automated solution. They've mapped out a progressive 5-layer AI architecture. Think of this as an assembly line for intelligence. A signal enters as totally fragmented noise at layer 1. Then, as it moves through layers 2, 3, 4, and 5, it gets progressively cleaned, analyzed, simulated, and finally matured into a clear, actionable warning. Let's look at how these steps actually work in practice. Now, what's really interesting about this slide is how the architecture handles that initial massive blast of data. In layer 1, the data acquisition layer, heavy-duty data pipelines filter, clean, and harmonize all that raw, structured, and unstructured data into a reliable format. It's all about sweeping away the initial noise. Then it flows into layer 2, where we begin spotting those early signals. Here, large language models and statistical anomaly detection algorithms take over. They scan the data to detect subtle trends in complex linkages that a human analyst simply wouldn't have the time or capacity to find. Once a candidate signal is actually spotted, it moves to layers 3 and 4 for some really deep validation. The MSK research team designed layer 3 to act as a multi-domain AI triage. This is where specialized, autonomous AI agents step in. They rigorously assess the credibility of the signal by cross-checking it against a collaborative knowledge base and running historical comparisons. If the AI agents decide, hey, this is credible, it passes to layer 4, simulation. And this is where things get super futuristic. Using digital twins, the system actually simulates the potential impact of the signal, assigning probabilities to different outcomes before the event even happens in the real world. It's essentially a virtual testing ground for the future. Finally, we reach layer 5, the response layer. The signal has now matured from a vague anomaly into highly validated decision quality foresight. At this stage, it connects directly to the command center. What's absolutely vital here is that every single step of this 5-layer journey is fully traceable. It provides actionable insights with a complete auditable chain of custody, so leadership knows exactly where the warning originated and exactly how it was verified. Section 3, Steep, Forecasting Global Threats. So we've got this incredible 5-layer architecture, but what kind of real-world threats are we actually scanning for?
And this brilliantly illustrates the cross-domain power of the AI system. The paper uses the STEEP framework, mapping out applications across 5 major domains: social, technological, economic, environmental, and political. For example, in the social domain, AI can detect coordinated disinformation campaigns that might be predicting civil unrest. Technologically, it scans for weaponized, dual-use IoT devices. Economically, it tracks anomalies like adversaries quietly acquiring port facilities. Environmentally, it models destabilizing effects like climate-induced migration. And politically, it monitors early, subtle shifts in diplomatic activity to reveal an adversary's intent long before any overt actions are taken.
The stark reality is that human analysis alone is almost always going to miss these low-visibility signals, especially when adversaries are actively trying to cover their tracks. But by fusing open-source intelligence with this highly automated AI-driven STEEP analysis, organizations gain a massive anticipatory advantage. It literally moves them from a reactive posture, where they're just putting out fires, to a proactive one.
Section 4. The human in the loop. Speed versus context. Because, of course, handing over your intelligence gathering to autonomous AI agents requires a massive reality check. The paper provides a really impartial, critical look at 2 distinct operational models here. On one side, you have the human out-of-the-loop model, full automation. The big advantage? Millisecond speed and infinite scalability. But it severely lacks political nuance, and a misidentification by the AI risks triggering an accidental, highly disproportionate escalation. On the other side is the human in-the-loop model. This introduces a decision lag, obviously slowing things down, but it brings crucial contextual understanding, strategic judgment, and strict accountability. Ultimately, the paper strongly advocates for a hybrid model. Let full automation handle the defined, basic tactical rules, but ensure humans retain ultimate command over complex strategic actions. Why this matters is perfectly summarized by the research itself. Human judgment has to remain central. The automation, the big data science, the AI, these are incredibly powerful tools for finding that needle in the massive noisy haystack. But once that needle is finally found, it requires human wisdom, contextual understanding, and tactical reasoning to decide what to actually do with it. Technology is a force multiplier here, not a replacement for human command. Section 5. Open source versus proprietary, strategic choices. This brings us to the final strategic dilemma presented in the paper. How do you actually build this foundational architecture? Leadership faces a really tough choice between free, open-source software in commercial proprietary platforms. The researchers outline that proprietary software offers incredibly fast deployment and very predictable operating expenses. But it comes with a massive strategic risk: severe vendor lock-in. For long-term military and institutional infrastructure, being permanently dependent on a single commercial vendor is highly dangerous. Free software, on the other hand, guarantees absolute sovereignty, security through transparency, and zero vendor lock-in. However, it does demand a much, much higher level of in-house technical expertise to actually build and maintain. So, the crucial point is that leadership must carefully weigh their internal resources. If a massive organization needs complete control, total ownership, and they already have strong in-house technical teams, the open-source route is strategically superior for long-term resilience. But if they need a solution deployed in under 6 months and totally lack internal engineers, well, they might be forced toward proprietary tools. It's a really delicate balancing act of budget, time, and the ultimate need for digital sovereignty. As we look forward, the research points to a totally thrilling frontier. The absolute cutting edge of weak signal detection is going to involve integrating digital twins with agentic AI in what are called zero-shot environments. This means AI models can perform incredibly complex threat detection tasks without any specific prior training. It's essentially acting like a brilliant detective successfully solving a type of crime they've literally never seen before. Multi-agent systems collaborating autonomously like this will soon completely redefine our lead time. The window between a threat emerging and an organization actually detecting it is going to shrink drastically. This explainer was based on the groundbreaking 2026 paper by Dr. Enes Kara Artslan and his team, published in Open Publications. It is an absolute masterclass in modern anticipatory governance, and it leaves us with one incredibly provocative thought to ponder today. As the digital hurricane gets louder and louder every single day, what critical weak signals is your organization failing to hear right now?